So this is a response to Sleeping Warrior that ever so kindly challenged me to show how sextants work on a globe. And this conversation with Sleeping Warrior actually came on the back of a video by Flatzoid. And what Flatzoid had done is snip out a little section from a video from 2012, so way before Flat Earth became a thing.
Alright, tell me your name.
Roohif.
Ruth, and how old are you today?
102.
102, so you were born in
1918.
1918. And we were just talking, and I asked you what shape the Earth is, and what did you say? What were you taught in school in elementary school?
I was taught in school that the Earth was flat.
And then what do you remember when they changed it to a globe?
Well, when they changed it, I remember when they changed it, but I can't remember the date or anything like that.
And did you believe them?
Yes, I did.
You did. Now,
I was young.
Right, and we all were told by people that we trust.
That's right.
Where did you go to school? Elementary school.
I went to Glen School in Hamden, Connecticut.
And in this video, the original creator, who actually claims to be a United States Navy navigator, draws this right-angled triangle with a horizontal line from the observer to the GP of the star. Now obviously this is wrong, so I told Flatzoid that and said I'd go over and let the original creator know. Flatzoid of course doubled down and said, he must be right because he was a captain in the Navy. Now I don't give a shit, so he's still wrong.
Don't get it, do you?
Now I don't give a shit, so he's still wrong. Now I don't give a shit, so he's still wrong. Now I don't give a shit, so he's still wrong. Now I don't give a shit, so he's still wrong. Now I don't give a shit, so he's still wrong.
Don't get it, do you?
So I went over to the channel and pointed out the error, but given this video has almost 500,000 views, obviously I'm not the first one to let him know, and at some point he had already updated the description to acknowledge that. However, the actual math needed to perform celestial navigation involves trigonometry on a sphere, which is very advanced math. And as such, you should watch this video knowing that right-angle trigonometry is not actually used in navigation, because the Earth is a sphere. So Flatzoid got massively owned by his own source, which I found incredibly hilarious.
Oh boy, let's go through it, shall we? Because you seem to be really missing out very critical parts here, Roohif. But that's how you usually do it. You do know this description has actually changed recently because of zealots like yourself who have a problem with him actually proving it's not a globe. Anyway, yes, he was definitely in the Navy and he definitely did navigation, and soon I will be showing everybody the people that did agree with him, also in the Navy, also studied celestial navigation, had no problem with the 90-degree sextants argument. Only you do. You know why that is? Because you are a cultist and you are true to your ways. Anyway, let's get to this actual description. Funny how in the description, he still leaves everything there. He just says the Earth is round oval after he's already done his mathematics with the 90-degree angle and his trigonometry and his triangles. You do realize if he really was wrong, he would either change his video or delete his video. Instead, no, he just added to his description to appease you zealots. So let's take a look at the older comments that totally destroy your fantasy. Okay, this is a comment from 5 years ago. Kudos to you, sir. Most explanations of the process bury the pupil in jargon without first giving a simple conceptual explanation. I, for one, thank you very much. And John L. Bales, agree 100%. Thank you, great job. Castaway, 7 years ago. Thanks, this is the best overview I've seen so far. I watched a few other videos and that went into great detail, but they never illustrated what those details were accomplishing. The drawing and simple explanation create context for the very detailed math involved. And Didi is just saying, agrees, excellent description. 1 year ago from Layman Laurie. I was also in the Navy, in the early 70s, as a quartermaster. Your presentation brought back some fond memories. For instance, how satisfied we would get by achieving a pinwheel fix when shooting stars. Not always easy when your vessel is rolling and pitching. I wonder if ships still carry chronometers. In any case, nice job, sir. He definitely has to know what was going on. Yeah, it's amazing that these people with actual experience agreeing with him. If he's so wrong, then they would have called him out on it straight away, wouldn't they? Especially this next one. Carol Barr, 7 years ago. Thank you for the refresher. I was a QM1 in the Navy as well, worked on the bridge plotting and charting, so she should know what was going on. Shooting bearings and ranges, LORAN and SHORAN. Right alongside the XO. I used to know celestial navigation as well. Many years ago, I was also certified as the deep sea diver. So, Mr. Roohif, do you think this person would know if that's wrong what he was saying? I think so. Who would I rather trust? Carol? Or some Roohif zealot that doesn't know what a triangle is? And it just goes on and on. 6 years ago, 5 years ago, 4 years ago. This video deserves a part B, where you work through the actual example. Good work on part A. Best description I've ever heard so far. That is the most simple explanation for listless navigation I've ever heard. Thank you. This is awesome. Thanks. I've always been interested in both in astronomy and history. So this is very cool to learn. The internet is an amazing thing. So much positivity. So 9 years ago from Table Class Math himself. Thank you for that wonderful comment. Clearly you know what you are talking about and bring back a lot of rusty memories for me when I was a Navy navigator. The goal of my video was to give the students a general sense of mathematics that goes into celestial navigation. Of course, I find it amazing that we can use the stars to locate a location on Earth, so I try to motivate students by using real-life examples of math to become more interested in the subject. Now this comment tells you everything you need to know on why, Roohif, you are so wrong. Do you see what is actually written here? This was 9 years ago. Did anybody here see any problem with the right triangle on a flat base? Answer? No. He is saying thank you that people are validating what he says. It brings back so many memories and to try and motivate students. And then from Basil 40, which is 1 year ago, from personal experience, this means he's actually used the sextant, and the site reduction tables are a massive time saver. Once again, someone that would have called him out if the math was wrong. I think everybody's starting to get the point here. Awesome class. If your teachers would use this method of teaching more students, would grasp the skills in mathematics and value its usefulness. Great job. Thanks for the great feedback. I agree with your comments. When I made this video, I just kind of credited as I was thinking about it. Nevertheless, the topic of navigation and teaching the mathematics around the subject is huge and offers several approaches. Thanks for watching. Not stating that, oh yeah, no, I did the wrong mathematics. I should actually change it, did he? Why I like this comment. Thanks for the comments. During the day you can use the sun to get your LAN, which is local apparent noon, which gives you the LOP, which is a line of position. I hope Mr. Sensible is paying attention. Celestial navigation is part of the overall navigation effort on board ships. Navigators also need to know the DR, Mr. Sensible, which is dead reckon or deduced position, which is updating your position by using your course, speed and last fix. So obviously you know where you're traveling and where you've been. Of course, the more you estimate your position using DR, the less accurate your position. Hence, using the sun during the day can help update your fix. So, triangulation, Mr. Sensible, not trilateration. And then you get the guy that was in the Marines, which is in the Army office, and he's not calling him out for his wrong math, which is really odd if it was wrong. Okay, well, I'm not going to read them all through for you because they all say about the same thing. You guys can actually go to his video and check all his comments, and you see when it does start having problems, you know, like this guy, Sean Hawkins, which is a zealot anti-flat earther, starts commenting, oh, how bad it is. Look at the time date he started doing that. I mean, it's literally only from the last month or so that you start getting these zealots, trolls, that commenting and saying, oh no, the math is wrong, the math is wrong. And what do all of these guys have in common? They're all very dedicated to their globe cult, and they all have no actually clue how to navigate or use geometry to start off with. So, what do we take from this? Why do we have to listen to globe anti-flat earth trolls who actually just have a belief with no actual substance of evidence to back up what they are claiming?
Anyway, let's have a look at Anthony's video.
Okay, this is a short video dedicated to Roohif. Roohif is a smarmy, patronising, condescending prick.
Good morning, Anthony. I love you too, champ. Handy tip before we start, though. Don't let Nathan catch you using Muppet vision, or he might want to stick his nutsack in your mouth and ask you how salty his balls are.
So good. So good and tasty.
Sextants do not work on a globe, for a variety of reasons, all of which are completely ignored by the anti-flat earth cult members.
Or the other possibility is that we've addressed all of them a million times, and you've just ignored them. But I get it, Anthony. Nathan's channel's dying, and that means your cut of the super chats is dying as well. So you guys need some content. I get it. Right, so first question is this one.
A legitimate question is, how do you get the GP distance? The distance from the observer on the right. There's Roohif stood on the ball. Notice I've got the ball underneath him.
Right, so if you had been listening, you'd know that you don't need any triangle to calculate the distance from the observer to the GP of the star. You'd know that you don't need any triangle to calculate the distance from the observer to the GP of the star. You'd know that you don't need any triangle to calculate the distance from the observer to the GP of the star. You'd know that you don't need any triangle to calculate the distance from the observer to the GP of the star. The way the geometry works on a globe is like this. You have me, the observer, somewhere on Earth, measuring an angle to a star relative to horizontal. Measuring an angle to a star relative to horizontal. Measuring an angle to a star relative to horizontal. Now there's been some incredibly silly talk in the last few days from the likes of QE and Mitchell from Australia, who both claim that the simple act of measuring an elevation angle proves that the Earth is flat. Now I already feel a bit dirty addressing this because it's really the lowest of low-hanging fruit. When we say we're measuring an angle relative to a horizontal plane, all we mean is that we are measuring the angle relative to the direction that is perpendicular to down.
You mean perpendicular to vertical, which would mean you have a new zenith every degree from the observer, and thus you do not have a horizontal plane.
And that's what auto levels and theodolites do. They have an internal mechanism that's effectively a plumb bob, pointing straight down, and then the device constructs a plane that is perpendicular to it.
Great, so you agree it's a horizontal plane, aka you don't have a curved surface underneath. That plane is horizontal. Your reference is horizontal.
And as you can see in both cases, that line does not coincide with the surface. On a flat Earth, it will be parallel to the surface, whoop-de-doo, and on a globe, the surface will drop away from that horizontal plane. Now, if you're using a sextant instead of something like a theodolite, then most of the time you'll be measuring the angle between the horizon and the star.
First off, we've been through this with you with the whole auto level thing, you know, where you put the two auto levels facing each other. Shit shrinks, dude, aka why it appears lower. It's very simple, called optical drop. And as for the sextant, yes, you're correct. A horizontal plane, which is horizontal. Horizon, horizontal. You debunking your own claims here that it's not a horizontal line.
And since the horizon is below horizontal, that's why you need to make the horizon dip correction.
So therefore, this is known as the HS, or the height of the sextant.
Which is also called the height of eye correction. And that leads me to my first question for Riley. But obviously any of the flirt can chime in. So question is, how do you derive the horizon dip correction on a flat Earth? Now, if you saw my previous video, you'll see that the almanac calculates the correction explicitly from the Earth being a globe.
Absolutely not.
And it incorporates refraction.
To dip or not to dip? That is the question.
So what's the explanation, champ? If you want to borrow the calculations from the almanac, then you're gonna need R for that. I also noticed that since this sextant argument started, that people have stopped saying that the horizon rises to eye level.
The mama, not 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 the...
That is just an outright lie. No one says it rises to eye level. We do say it rises relative to eye level, because it's not physically rising. It's only an optical illusion.
And that makes sense, I guess. If you want to claim the sextant as FE proof, then you have to also accept the horizon dip correction.
Roohif, it's quite self-explanatory. Your eyes are not embedded into the horizontal water below you.
Anyway, back to working out the distance over the ground to the GP. So we've established a horizontal, either using a theodolite or maybe something like a bubble sextant, and measured the angle to the star. Or we've measured the angle between the horizon and the star and then corrected for the dip.
Sorry, Roohif, please explain to me how you're going to correct for a dip that's not there if you're using an artificial horizon. There's no dip to correct to.
Either way, we have angle alpha. Now the key thing here is that because the stars are so far away relative to the size of the Earth, then these two yellow lines are effectively parallel.
Mama.
You do that one more time and I'm gonna throw you across the room.
Not the mama! Wee, oof.
You know, you people love to make that argument. It should be parallel because of my belief if something's far enough away, it's going to be parallel. Well, Roohif, would you be able to demonstrate this for us? And while you're at it, please stop making lies up that you are actually having an angle. You first need a flat base to be able to measure that angle. No flat base, no angle. Full stop.
So let's assume that the star we're looking at is Polaris. So the GP is the North Pole in this diagram. Now, according to astronomers, the distance to Polaris is 434 light years, which is 4.1 quadrillion kilometers away. Now, that's 4 with 15 zeros after it. So we'll take a guess here and say those yellow lines are about 5,000 kilometers apart. So if you want to actually use a triangle here, then those two lines are way less than a billionth of a degree apart. So yeah, let's just call them parallel.
Yeah, let's just call them parallel. We don't need actually any evidence for it, but why? Because some scientist has a belief that it's that distance, so it must be that distance, and therefore it's parallel.
Anyway, if you successfully graduated the 5th grade, you'll see that this angle beta is just the complementary angle to alpha, and it's also the same angle formed by this sector of a circle.
You know, for someone who keeps claiming there's no triangles involved, you do sure show a lot of triangles. Just have to mention that to you.
So let's say that alpha is measured at 40 degrees. Then we know that beta is 90 minus 40, which is 50 degrees. And on a circle with radius 3959 miles.
Hold on, where did you get the radius, Roohif? Oh wait, I forgot. You're too stupid to understand the black swan argument, to know why you don't have a radius.
We have a circumference of 24,875 miles. So if we want to know what 1 degree of that circle is, that's where we get 69 miles per degree. And if we measure 50 degrees, then we just multiply by 69.1, and we get 3,455 miles from the observer to the GP.
So that would be a circle of equal altitude with over 3,000 miles. You do know on your geoid you wouldn't be able to have one circle of equal altitude, just to let you know. Not to mention you didn't show how it's deriving the dip correction here.
So that's question 2, Anthony. How do you calculate the distance to the GP on a flat Earth? And I know your answer is 69 miles per degree, but you just saw that it's derived from the Earth being a sphere.
No, Glenn. That math is derived off of a belief of having a sphere. There's a difference from, doing equations because it's a sphere and doing equations based on because you think it's a sphere. Huge difference. Have you ever heard of zenith distance calculations? Well, how it works is you get your 90, the degree, you minus it or plus it, and that's where you get your lat and long, and we know it's Cartesian coordinates, and that's going to give you a circle of equal altitude, and that's going to give you your distance if you look on a map. Very simple.
So you're going to need R for that, champ. Alright, next bit. Riley somehow thinks that we can't measure light that's curved through our atmosphere.
Now, obviously remember that there is no line of sight to the horizontal on their model that's straight because of 76R. The line out to the horizon or the set horizontal on their model, because you're looking through the optics of the sextant, is subject to refraction at the rate of 7 over 6R and is therefore a curved line. So their argument immediately fails. Okay? Everything on their model is a curve. It's applying curvilinear geometry. Right? It's not applying Euclidean. There are no straight lines on their model.
Jesus, where to begin? Alright, so Riley seems to really struggle with curved lines and how we measure them. So again, enjoy the Muppet vision. Because of the density gradient in the air, light will curve.
Totally agree with you there, Glenn. Light will definitely curve, always having refracted rays, no matter the surface.
And this happens regardless of the shape of the Earth. So all we're measuring here is the angle at which light is coming into the lens. So if you want to whinge about an angle needing 2 straight lines, that's fine. We'll just add in a tangent to the curve at the point at which it enters the lens. Easy done. So number 1, light curves regardless of the shape of the Earth. If you want to make a positive claim that light can only bend on a globe, then boy do I have some laser tests to show you. Number 2, we're just measuring the angle at which light comes into the lens. So in reality, the path that light takes is curved, and that's why we correct for it. And we don't just adjust for it in the horizon dip, we correct for it with the elevation angle to the star as well.
We've been through this already, Glenn. The dip angle is literally just your elevation above the ocean. Nothing more.
So again, if you accept that celestial navigation works as is, then you're going to have to accept that it already makes corrections for light bending. Number 3, 7 over 6R obviously only applies to a globe. If you want some formula for light bending on flat Earth, then you're going to have to derive it by yourselves.
As far as I know, I think Flat Earth Data has actually made an equation for this. Would be interesting to see you actually try and debunk that one, Roohif.
So not only does 7 over 6R only apply to a globe, it only applies to observations made within a couple of degrees of horizontal. So I don't know if Flurfs have ever actually bothered to look at the almanac, but these altitude corrections for the star get smaller and smaller as the angle gets bigger and bigger.
Ah, so like perspective. The things get further away, the angle is getting more limited. Thank you, Roohif.
Until there's 0 refraction when you are looking straight up. Number 4, and curves exist in Euclidean geometry. Anthony's not the only guilty party here, so all the flurfs seem to get really confused when it comes to curves and Euclidean geometry. Oh wow, look at that! It's a curve in Euclidean geometry. You remember the equation for a circle, right, Anthony? Maybe you don't. So on the left, we've got a two-dimensional Cartesian plane, and on the right, we've got 3D space. Both the circle and the sphere are within Euclidean geometry.
Yeah, got no problems there. I agree with that. Both Euclidean.
And this is the two-dimensional surface of a sphere in non-Euclidean geometry.
Problem is, we live in Euclidean space. You know, 3 space, 3 dimensions, not 2 dimensions, Roohif.
So the point I'm making here, Anthony, is that just because I'm dealing with curves and circles and spheres doesn't mean that I'm bound to a particular geometry.
Sorry, if we live in 3 dimensions, your geometry is set by 3 dimensions, Roohif.
If someone describes a sphere in X, Y, and Z coordinates, then they're clearly using Euclidean geometry. But if someone's giving you latitude and longitude, then the implication is that they're referring to non-Euclidean geometry.
But I always thought something like the WGS84 is Cartesian and Euclidean geometry. Isn't that how you guys describe your globe?
So the surface of a sphere. So the context matters. Just because you're talking about spheres, it doesn't mean you're using one geometry over the other. So you can be using Euclidean geometry for something, and then transform those XYZ coordinates into a latitude and longitude, and start using spherical geometry.
Yep, makes sense, you know, because you do have to start with a flat base to make it a sphere, so...
Alright, back to Anthony's video.
I know this is begging the question, but I've got to do it for their argument to show how it doesn't work for them. But it only works for us. But we've got Roohif here, he's on the right hand side, he's on his ball, and he's set in his zenith.
Right, so this whole begging the question bullshit needs to be addressed again. So I talked about it a few years ago, but clearly they are not understanding. So flurfs have enormous issues with this idea of presupposing something like the Earth being a globe. So let's have a look and see if that's a valid objection.
Of course it's a valid objection, because it's logic. If you're going to beg the question and then affirm the consequence based on begging the question, and even though it's wrong, just because you beg the question and affirm the consequent, you've literally just fabricated evidence that isn't really evidence. So yes, it's illogical to think it's not a valid argument.
So first of all, begging the question is when one of your premises already has the conclusion in it. So it's effectively circular reasoning. And that's an informal logical fallacy. So an example of this might be 2 Timothy 3 verse 16 says that all scripture is given by inspiration of God, therefore the Bible is divinely inspired. Now obviously you can see the circularity in that and why the argument fails. But what flurfs are actually referring to when they say begging the question is usually a formal logical fallacy called affirming the consequent. And it goes more like this. So if the Earth is a spinning globe, then the weight of an object will correlate with latitude due to the centrifugal force. In reality, the weight of an object does correlate with latitude, and the conclusion is therefore the Earth is a spinning globe. And that, my friends, is a formal logical fallacy. But flurfs seem to think the problem is with the if statement. So if the Earth is a spinning ball, and as soon as you start with that if statement, that's when Nathan will hit his mute button and start his usual pathetic tirade about presupposing a globe.
Yes, the word if means you're already begging the question because you're saying it is a globe and then affirming the consequence based on it. So just validating my previous statement.
But I do recall flurfs being very fond of this particular argument. And oh, looky here, what does it start with? If the Earth is a sphere with radius 3959 miles, blah blah blah.
So you don't have a problem with begging the question yourself, but if someone else has to use your argument against you with modus ponens and modus tollens, then there's a problem.
So clearly flurfs don't have any problems with presupposing a globe. They're doing it with the black swan argument, and they're doing it every time they use a curve calculator as well.
That's correct. You know, putting your globe model to the test. So we started on the premise of it being a globe and then showing why it's bunk.
So what both sides are doing is presupposing a globe for the sake of the argument. Then we go and check the prediction against reality and see if it matches. Unfortunately for the flurfs, the black swan argument fails miserably because it ignores the atmosphere.
So I was definitely correct. You do not understand the black swan argument. It is about the atmo. It's about your refraction. It is proving that it's all optical and not physical curve. How much more simpler can we make it for you? If it's geometric, it cannot move.
So the second half of that sentence is just false. So here's a bit of a flowchart for what's happening logic-wise for these so-called globe-killing arguments. So you have some proposition P, and if P is true, then some other proposition is true. So in this example, we're using Riley's Maghold Lighthouse claim from a few years back. So first step is to assume, for the sake of argument, that the Earth is a globe, and then work out what the consequences would be.
So good. So good and tasty.
So you'd plug it into a curve calculator, it would spit out a hidden amount, and you'd use that to declare that you should not see the lighthouse. Then you compare that to what you actually observed in reality. If you did not see the lighthouse, which is what you expected if the Earth is a globe, then whoop-de-doo, you can't make any conclusions from it. If you did make a conclusion of, therefore the Earth is a globe, then you'd be committing the fallacy of affirming the consequent. If you did see the lighthouse, which Riley claims he did, then the conclusion would be valid. Earth is not a globe. Unfortunately for Riley on this particular occasion, he was mistaken about what he saw.
I know you're just trying to explain the modus ponens, but I just have to point out, you do know what you're seeing could also just be optical.
And if you're at all interested in how this panned out, I'll leave a link in the description. There are a couple of other errors that flurfs tend to make, and both of them are in that second step. So the one that says, then I should not see the lighthouse. So in this example, there's a hidden assumption that the atmospheric conditions are typical, and that you'll be applying standard refraction. In reality, though, the conditions might be conducive to extreme refraction, and under those conditions, maybe you should see the lighthouse.
Ooh, extreme refraction. No, Glen, that is literally just you guys making up excuses on why your globe doesn't work, so you can reify it and still see, it's extreme, so it has to still work. In the meantime, your geometric horizon has never ever been observed. You know why? Because it doesn't exist.
The other error is when they just make a completely incorrect prediction. So for example, the if statement might be, if Earth is a spinning ball, then I should be thrown off like I'm on a roundabout. And if you've ever calculated the forces involved in this, you'll realize that the then part of that statement just doesn't follow, so the argument fails that way. The last point I want to make when it comes to logic is that pretty much every logical argument that flurfs make begins with, if the Earth is a spinning ball.
Now that's just baloney. You know, like me giving an argument now. What you seeing? Could that just be optical? Where did I say anything about a globe or flat Earth?
I don't think I've ever seen any flurfs make any sort of positive claim for their position. Like, if the Earth is flat, then I expect to see X. And obviously they can't do this because they don't have any kind of model. And if they don't have a model, then they can't make any sort of prediction for what they should see in reality. And that's why all you get from flat earthers is just post hoc rationalization. So you'll show them something like Canigou or San Jacinto, where there is 2,000 meters of mountain below the horizon.
No, Roohif, we have been through this so many times. It's literally just optical. Their limited angle is causing the floor to foreshorten and occult the bottom of that mountain. That mountain is not physically 2,000 meters below the horizon. It is just optically occulted thanks to foreshortening and perspective.
And they'll just throw phrases like, it's the limited angle, or that's just perspective. And this is why that second step of making a prediction from a model is so important. It shows that you actually have some understanding of how things work. If you can't make a prediction, then you don't know how things work.
Can't make a prediction, so you don't know how things work. Let me point you back to this Blackpool photo. Remember, this is analysis you did when I explained to you why it's the limited angle while you validated it. You see people that 0.1665. That is a larger angle than the 0.1095, is it not? Is that 0.1665 angle also closer to the observer? Definitely. So, the larger, closer angle is limiting the further, smaller angle, thus the limited angle. We know what we're talking about, Glen. It's you that validates it for us every single time you post something.
So sorry for that extended rant. Let's get back to this absolute abomination of a diagram in Riley's video.
Let there be no doubt, we do have the three values that we need. We've got the number one, the measurement of the angle from the observer. Number two, the distance in time of the star to the zenith. And we've got number three, we've got the right angle 90 degree. And at that point, the trigonometry can be done.
Then fucking do it, Anthony. All you Muppets keep claiming the trig works, but no one seems to be able to put the fucking numbers in. And this shit about measuring distance in time. Holy fuck, Anthony. Take your medication.
Let me ask you something, Roohif. If you have the sun sitting at my GP, and it has moved 15 degrees in an hour to another GP, have we not now measured the distance with time that it's moved across that plane?
So Anthony, I've answered everything in your video. Now let's see if you can answer me. So the questions again. Number one, how do you derive the horizon dip correction on a flat Earth? And number two, how do you calculate the distance to the GP on a flat Earth? And I mean actually do a worked example like I did in this video. And remember, Anthony, a nautical mile is defined by 1 arc minute of latitude, so you're going to need R for that, champ.
Okay, number one, how do you derive the horizon dip correction on the flat Earth? I failed to see where you showed us the dip correction, how it came to math for the globe. I did, however, see you explain your 1 degree is 69.1 miles a degree because you believe it's a sphere. We can just say that 1 degree is 69.1 miles because it's an optical angular measurement, because you are seeing the declination optically, not physically. So in other words, every 1 degree we measure optically is equal to 69.1 miles a degree. Simple. Now we actually look at a dip. You see, is the sextant embedded into the ocean? That would be no, Glen. It's not. That's why you have a dip correction in the first instance on the ocean, because you need a flat horizontal baseline, a 0 degree. Have you ever wondered why the micrometer is there, Roohif? It's just to make it more accurate for you, so you know you get your hours, minutes and arc seconds. That is how you're going to know what your dip correction is above the water. Nothing to do with the curve. The only arc is the actual angular measurement. How do you calculate the distance to the GP on a flat Earth? That's very simple. It's the same way you guys do it on the globe. The zenith angular distance calculation. The only difference is we're not having a curved triangular base. We have a flat triangle base. You know, like a triangle's supposed to work. A flat base. Now that linear distance is just a mirror from the angular distance below. That's how you get your distance.
And they'll just throw phrases like, it's the limited angle, or that's just perspective.